Okay, circle graphs. So we did bar graphs, we did dot plots, we did box and whisker plots, we did all the things. This is the last part, circle graphs, which looks like a circle and it's broken up into percentages. Yeah, kind of the same. Pie chart, circle graph. It's a graph that displays data as parts of a whole, just like the bar graphs, just like everything else we've looked at. In a circle graph, the percents add up to 100, since the entire circle represents the whole. One whole, 100%, that's all of it. The data represented in a circle graph can be used to solve problems, including part to whole. Remember how we set that up? Part to whole, comparisons, and equivalence. So example 1. And when we did that puzzle the other day where you had to find the percents of stuff, it's kind of why we did that, so you can have some practice for this page. Example 1, the circle graph shows the percent of types of flowers planted in a flower garden. If there are a total of 150 flowers, how many more, that tells us we're going to subtract, how many more of them are impatient than begonias? Sorry. Okay, so there's 150 flowers, and they break it down into percents of it. So 12%, 28%, 10%. We're just looking at impatiens and begonias, okay? So if they said there were 150 flowers, we're trying to figure out how many flowers that is. They only gave us a percent. So to figure out these guys, 36% of 150, just like that page we did the other day, turn that percent into a decimal. How do we do that?
Move it over to the right.
2 spaces to the left.
Oh, yeah.
Turn it into a decimal, 0.36, and multiply it by the whole. So 0.36 times 150, and they already gave it to us, 54.
I thought you were getting the 30.
Okay, then for the begonias, 14% of 150 total. That's how many they said were total altogether. How many flowers? So turn 14% into a decimal. Remember, if it's a whole number like that, put an imaginary decimal at the end, move it 2 spaces to the left. So 0.14 times 150, and they got 21. Okay, so the question was, how many more of them are impatiens than begonias? So they had to subtract 54 minus 21, and we get 33. 33 more impatiens than begonias. Example 2, the circle graph shows the results of the enrollment of a school's fine arts classes for next year. If there are a total of 400 students, so this is representing 400 students. But they have just given you the percentages of it. So 12% of the 400 are in drama, 26% choir, 22% art, and 40% are in band. So if there's a total of 400 students enrolled, what fraction of the total number, so total number is going to go on the bottom, what fraction of the total number of students are taking band? So we're going to look at band over the total. Okay, same thing, that 40% turn into a decimal, so that would be 2 spaces to the left, 0.4. 0.4 times the total number, because we want to see how many students exactly took band. Okay, so when they multiplied, they got 160. So 160 students are going to be in band. Now you have to turn that into a fraction like they said.
A fraction. So like, something like 2 kids.
So same thing, band, how many kids are taking band? Over the total. So 160 kids are taking band out of the total 400. And they reduced it down to 2/5. So 2/5 of the total students are enrolled. Okay, so let's look at exercises down at the bottom. Exercise 1. Refer to the circle graph in example 2. So that's this one, the fine arts class. How many more, what does that tell us? How many more?
Subtract.
We're going to end up subtracting. How many more students are in band than choir? So what are the 2 things we're going to subtract?
Band and choir.
Okay, band minus choir. We already know how many kids are in band, right? We just figured that out in the last example. So 160. Now, how do we figure out how many kids are actually in choir?
26.26.
Okay, so I turned that 26% into a decimal. So that's going to be 0.26. And I want to multiply that by what? 400, the total amount of students. So 400 times 0.26. Remember, if you multiply with a decimal, put whichever one has the most digits on top. That, I'm hearing the right answer. So there's 104 kids in choir, so we're just subtracting that. 160 minus 104. So 56. So there's 56 more kids in band than in choir. Okay, example 2, refer to the circle graph in example 1. So that's the flowers. What fraction of the flowers are marigolds? So there's 150 total, right? So that's going to be my bottom number. But I have to figure out how many marigolds there were. So how do I figure that out?
0.12.
Okay, turn that into 0.12 and then do what with it?
Multiply by 400.
Multiply it by 150, the total. So
Oh, I thought we were talking about that.
150 times 0.12. So then 0, 5, 1. I got 2 places behind my decimal, so there's 2 in my answer. Did y'all get 18?
Yes.
Okay.
Is 18 the answer?
So can we simplify this?
To 334.
Surely we can.
6 over 50.
Good. 3 can go into 18. 6 times. 3 goes into 150. 50 times.
Divided by 2.
And we can keep on going.
Yeah, divide
Divided by 2.
25.
3 over 25.
There you go. Can I reduce that anymore?
No.
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 No.